All right, hello again. This is Jeff Scott of Rankin Technical College. We've been going over Course Technologies JavaScript 6th edition text, and I'm up to Chapter 4 of 12, Debugging and Error Handling. And in this chapter, our objectives: we want to be able to recognize different types of errors, trace errors using dialog boxes and the console, use comments to locate bugs, trace errors with some of the different debugging tools, and write code to respond to exceptions and errors. Now, all programming languages have a certain type of syntax, which are rules of the language. And when you think about it, you can take it even further. Even the English language, for example, what do? We take our words, we make them into sentences. We take our, for writing, we take our sentences, we put them into paragraphs. We take our paragraphs, we put them into pages. We take our pages, we put them into chapters. We take our chapters, we put them into books. In much the same way, programming languages have a syntax. And as an example, with JavaScript, you've already seen this when I went and changed the word alert, A-L-E-R-T, to alert, A-L-E-R-P, then I got a syntax error. All right? You can also get two other kinds of errors when you're running code. One is a runtime error, and as the name suggests, you don't get it until you run the program. All right? And the other one is the hardest. It's a logic error. And the reason that the logic errors are the hardest is most programmers, whether they like to admit it or not, think of themselves as basically being infallible and unable to make an error like that where they mean to do one thing and they do another. Typically, logic errors are the hardest for people to find in their own code. All right? I've had students come up to me in the past and say, hey, I don't know what's wrong with this code. And we'll look at it together and we'll find it. And they've come back to me and said, I don't know how that happened because I didn't do that. Well, then there were gremlins, or somebody came in and did it because it's there. So a bug is a program error that causes your program to either function incorrectly or not at all. And debugging is the process, as it says there, of tracing and resolving or finding errors in a program. Again, syntax errors are errors in the language. They occur when the interpreter doesn't understand what you're trying to do. Okay? Runtime errors, as mentioned, is something that you encounter when the program is executing. Notice it says not necessarily JavaScript language errors. There are different things that can cause this. It can be caused by a syntax error, but it can be caused by other problems too. Logic errors, again, flaws in the program design. There is an example, kind of what I mentioned before. You want to say 10 divided by 2, but accidentally put 10 times 2. So that's going to say 10 divided by 2 is equal to 20, which isn't what you're going to want. Logic error, here's an example. An infinite loop. So you're never changing the value of count in the for loop above because you meant to say minus minus. All right? Or if you'd have put plus plus here, then instead of getting closer to 0, you'd be getting farther away from it. All right? So, as it says, the first line of defense in locating bugs, have your browser console open. Even before that, I would call that, the first line, but let's call this the 0th line of defense. Go back, and if you're really having problems, don't at all be afraid to run off a hard copy of your code. Some people find it much easier to have a hard copy, a paper copy of their code, so they can go through it and mark it up. All right? With runtime errors, as it says, sometimes you'll get error messages generated by the browser. All right? And it'll look something like this. If you forget a missing curly brace or something like that. I'll always remember that years ago I had a student and he had about 10 or 11 pieces of paper on the floor. Then they were literally all spread out one morning, and I said, "What are you doing?" And he said, "I'm trying to find out the problem in my code." And I said, "Well, what is it?" And he said, "Well, I've counted, and I've got 43 left curly braces and 44 right curly braces. So I've got one too many right or one too few left, and I'm trying to map them all up." And he was literally drawing with a pen to see what went with what. All right. We'll talk about ways that you can probably better that in just a bit. Now, when you get an error message, one thing to realize is that typically the error message will either be on the line in question or close to the line in question. It should be somewhere between line 1 and the line that it marks. It shouldn't be after where it marks there you're being an error. Okay, but it's not an exact indicator as it says here. Some browsers do not strictly enforce JavaScript syntax. Again, with JavaScript being, as we already mentioned, with JavaScript being a loosely typed language, you can sometimes get away with different things. If you always use good syntax, as I mentioned before, it's possible for you to write JavaScript programs that don't have semicolons at the end of every line. But you should anyway. All right? In many ways, it mimics real life because there's certain things in life that it would be easier not to do. It would be easier not to have car insurance. It'd be cheaper, but then what would you do if you ever got into an accident? All right? But then people say, well, geez, I've been driving for 50 years and I've never had an accident and I've paid thousands in car insurance. Yeah, what can I tell you? Always thoroughly test, and test with every type of browser you possibly can. And every version of every browser. Syntax errors can be difficult to pinpoint. If you think you've got several errors in the program, you should always work from the top down. Few common techniques are helpful in tracking down bugs. You can trace. So in other words, let's take a look at an example here. So I'm grabbing what I did in the last chapter for chapter 3. I'm going to call this chapter 04. All right. And let's see. Well, we've got index and we've got functions. Let's open them up and see what we've got in here. All right. We had that program that we had done earlier. And we had all this stuff that's in here. Let's remove, oh, I don't know. We'll remove this, and let's remove all of this. So what we have left here, I'm going to uncomment stuff out in just a minute, but what we have left here is where we were putting in a number, and we were saying if it was a number, and okay. So let's suppose we put in a logic error. Okay? So, in other words, where this is supposed to say even, we said odd, and where this is supposed to say odd, we said even. All right? So, let's save this, and we'll run the program. Well, let's enter a number. Let's enter 12. 12 is odd. Well, you and I can all look at that and know that that's a problem. But your first inclination when you realize that there's a problem there might be, well, maybe there's a problem with my formula. And there really is no problem with formula. Okay? So what you should do, again, you start real simple. So you run the program again. And I'll put a 1 in there. Well, it says 1 is even, so I know there's a problem. And I'll put a 2 in there. And it says 2 is odd. So we know there's a problem. How about if we run it and put a 0 in there? It says 0 is odd. So again, you know there's some kind of a problem with the program. All right. So we could put alerts in here. All right. So in other words, we can come in here and we can put an alert right here and say the result is plus result, and then we'll put in a couple line breaks as we have been doing. All right, so let's go run the program again. 12. Well, it says the result is 0. Oh, somehow our line breaks have gotten screwed up, but it says the result is 0. That's a good thing. All right, I guess that's an alert. We don't put line breaks in there. But the result is 0. Isn't that a good thing? Because it said when we tried to divide 12 by 2, there was no remainder. So that's a good thing. So that showed that that particular part of our program is working. All right, let's do it again. And let's pick a number. How about 53? Just made that, up. So that should come back with a 1. And it is. The result is 1. That's a good thing. All right? But then it says it's even, so we know there's got to be a problem here. Well, if we know that that result is correct and the problem is printing out in here, then we know we've isolated where the error is. So if it's a 0, we're supposed to write, we're supposed to write there. We're supposed to write even there. And that one's supposed to be odd. Again, those are classic types of logic errors. We all make them. Now when we run it again and we've got 12 in here, result is 0 and 12 is even. Good. We run it again. Remember, if we put junk in there, we changed it to 37. The result is 1 and 37 is odd. Now, sometimes when I write code, and it just depends, but I'll even take these lines that I put in here to test, and I'll just comment them out. But in case I make changes later, now I know where I had some of my lines that I was testing code in. All right. 12 is even. 57 is odd. Okay, we fixed that problem. Great start. Okay. So here's other examples that they've gotten here with the alert so you can try to find things. Okay. What's the drawback? You must close each alert dialog box for code to continue executing. Yeah, that's a drawback. It's kind of a pain in the butt to work with. But you can put it at any point you want in the program. That's one of the things that's nice about it. All right, there's something called console.log where you can log values. All right, so they've got this calculate pay function here. All right, let's grab their whole function and let's take a look at it. So let's grab literally, I'm going to try to grab all their code here. All right, and I'm going to take it and I'm going to put it in here. All right, so I'm going to go back to all this stuff that I've been working on in here, and I'm again going to comment all of it out. All right, so it's all commented out except for the last line, which is our ending curly brace. Okay, so I've commented all that stuff out. Now I'm going to come in here and I'm going to paste that in. All right, it's called calculate pay. Okay, we don't even need our main anymore then. That's groovy. Groovy? All right, that's fine. So I've got that. And then we're calling calculate pay at the bottom. Yeah, that all looks fine. There's the beginning. There's the end. So now I can actually comment out this line too. But there's a problem in here someplace. We have to figure out where it is. All right, we've got var pay rate equal 15. One thing I like to do is always, as much as possible, line this stuff up. To me, it just makes more sense, and I can see what's going with what. So the gross pay should be there, pay rate times hours, so that should be, well, it's, in my opinion at least, that should be 600. And then federal taxes, we have here set at, looks like about 7%. State taxes at about 4%. Social Security, you know, again, you can see the different percentages that we're using here. So we're doing all that, and then we've got our net. Now, what some people like to do, and you don't have to do this, of course, but what some people like to do is to literally work out an example like this by hand, so you know exactly what you're doing before you do it. I don't think that's a bad idea whatsoever. All right, so here's our console log. All right, so that's gross pay minus federal pay taxes right there. So that should be the net pay, yeah. And then we say net pay, we have to multiply the net pay by the state taxes, and then figure out what that problem is. All right, then by Social Security, and figure out what that amount is. And then finally by Medicare, and figure out what that amount is. And then when we get all done, we return the net pay. All right. And then this line down here basically says call this function. All right, we don't need that call to the function there like they have, because we can put that in here. So this is now called calculate pay. So we can call calculate pay right here. All right, so we've saved, nope, save. Always make sure you save. It's another big thing. I do that all the time. I make changes, don't save, and then run the program. Well, doesn't seem to like what we've done, so let's go take a look at it. Well, one nice thing, and actually that isn't true. Let's see. We're doing console.logs here. So when we come and run the program, all right, let's open up our console. And I'm trying to remember how we open it up for the log. It should actually come down here. This is our log area right there. So, okay, gross pay is 600. All right, well, there's a start. The gross pay minus the federal is this. The gross pay minus the state is this. Well, we can hopefully see a problem. Our gross pay is going up instead of down. See that? 600, it went down here after we took out our federal, the 559 could. After we removed our state, oh, it went up. It went up like $10,000. So there's got to be some kind of a mistake, I would think, in our calculation for our state. So we go back and we take a look at where that is. And actually, you're best off right here when you're starting to do this. Again, I said this to you before, you do a little bit at a time. Literally, you do a little bit at a time. So I'm going to run this again. And again, open up my console, right down there, and then run the program. All right, the gross pay is 600. Good. That's a good start. 40 times 15 is 600. That's a good start, right? Okay, so now we can start uncommenting things. All right. So, there's our federal taxes. All right. There's our state taxes. There's our Social Security. So we can also log each one of these, right? So we can come over here and say console.log Fed taxes are plus federal taxes. Now think about this. We know that this is 600. So we can do this by hand if we want. What I mean is I'm going to come up here and I'm going to find under my accessories, here someplace, I'm going to find the calculator. All right. And I know the first thing I did here was 40 times 15. And I know that worked because I saw the 600 before. So I'm going to say 600, because again, that's my gross pay. I'm going to multiply that by this amount right here, 0.0694. All right, so I want to multiply that. So they want to take that 600, I want to multiply that by, I'll try it again, 600 times, and then can we paste that in? Yep. And that equals what? $40.76. So if I take $600 and I subtract from that $40.77, all right, so about $41, okay, it should give me around, this amount here should be around $559. Okay, as you can see, again, the way I'm working this is I'm doing a little bit at a time. All right, so let's see. Oops, that's not what I wanted. Launch? No, not that either. Boy, oh boy. Run your HTML files. Okay. Whoop. And remember, I wanted to open up my window here. All right, so let's try it again. Uncaught reference error. Calculate pay is not defined. Well, I maybe have commented something out that I shouldn't have. I don't know. Calculate pay. Calculate pay. You know what? Let's make this main again. You can call this, really whatever you want, but I'll just make it main here. All right. And I'm going to make it main down here too. Okay. Now, I may still get an error, but if I do, we'll work through it. All right. So into Chrome, before we run this, we'll again open this up. All right. Main is not defined. Well, it seems to me missing parenthesis. All right. And I can try to find out where that is, but it looks like functions 2 on line 9. So we go to functions 2 and we go to line 9. Fed taxes are, ooh, I didn't put in the parenthesis. There you go. It was telling me. All right. So let's go back and try it again. F12, run the program. All right, so gross pay is that, and there's our federal. So that's working so far. All right, and again, I can put as many of these log statements as I need to put in there. All right, so now I can come in here and say this, console.log gross minus fed taxes equals, and I can literally just put in here gross pay minus federal taxes. So I'm doing that literally right inside of here, and there's nothing wrong with doing that. All right, so we'll launch it again. Again, we'll bring this up, we'll run the program. All right, so gross minus federal is 559.236. So far, it looks like it's working just fine. Now, what some people like to do is once they get to the point where they've got a bunch of stuff in here that's working, they like to comment out these console.logs. I'm just going to leave them in, though. All right, so here we've got we want to put in the next line here where we're figuring out our state taxes. And I'm going to do the same thing. And if you say, what do you mean? Just watch, please. So I'm going to say here, state taxes are, and again, we want to change that from federal to state taxes. And then we want gross minus fed minus state taxes. Oops, not equal. And let's just put this on another line, because otherwise it's going to scroll right off the screen. So this minus state taxes. Well, again, our state taxes were this, right? Okay, so we come back, we bring up our calculator again, and I'm going to clear and say 600 times that 0.476. So our state taxes should be $28.58. All right, so let's see if indeed that's the case. I mean, you can see there's a natural progression that we're going through here. All right. All right, so our gross, that's all okay. I must not have saved. And of course I didn't. So let's go back to here, see if we can refresh and run it again. All right, so our state taxes, $28.56, that's correct. So if we took 40 and 28, that's about, what, $69 right there? So it should be about $531, and it is. So far it's working. It's not a problem so far. All right? So we know everything in here is correct. So now let's check the Social Security. And, you know, we can keep working our way down, and I will. I can already see what the problem is. All right, so I'm again going to do the same kind of console.logs that I just did. And here we'll say Social Security is, and that'll be Social Security. And then here we'll say gross minus fed minus state minus Social Security equals this. Oh, I guess I needed that line and I didn't copy it down. Gross minus fed minus state minus Social Security. Okay, and again, you can see I'm working my way down and down and down. I'm going to bring this up again. All right, so Social Security, $37.20. Yeah, and that looks like that's about what I took off. So you can see, so far, everything looks like it's working. So you're like, wow, well, then why are you doing this, Jeff? You'll see why in just a minute. All right, so we're going to add our Medicare. I'm going to put that right here. So we're going to say Medicare is all right, and I really should be very consistent here with my capitalization. It just makes it that much easier when you're working with stuff. All right. Again, develop some kind of a standard and stick to it. So this is Medicare. It's gross times this. So Medicare is this, and that's Medicare. And gross minus fed minus state minus Social Security minus Medicare is equal to this minus this minus this minus Medicare. All right. We again come back. We again refresh. We bring that down. Well, now it looks like that was about $8 or $9, and that's about what I took off. So everything we've done so far says our program is working and it's logical. Here's where it breaks down. This line. All right, so actually gross pay minus fed taxes, okay, but we don't want to keep multiplying it by these. We want to be subtracting it by those. So we'll leave this. We don't want to do a var either because that's creating a new variable. Well, I guess we didn't have one before, so that's fine. var netpay equals this. And we'll do a console.log. All right. So netpay would be gross minus, well, we've been doing all these all along. So now I can start getting rid of I can just keep my Fed tax. So I'll tell you what, I'll comment that out. And I can remove that one. And I can remove that one. And I can remove that one. All right. And I can run the program again. Oops. Gotta hit my F12. Sorry. Let's run it again. All right. So there. Federal, state, Social Security, everything looks like it's okay. But here's where the program starts to break down. This shouldn't be net pay times equals. It should be minus equals. And notice if we do that one, now we've got our current net pay, and now we're subtracting our state taxes from it, which is what we want to do. All right, see how it's going down, but it's going down by the amount that it should be going down. So in other words, if I go back here now and take all these off and change all of these to minus equals, all right, every one of those, and come back here, run my program again, bring up this, and now run it. Now look at what we've got. Our final is $484.75, which is about what I would think from $600 that it would be. And there are no errors showing. So I made that maybe a little bit more difficult than it had to be, but we went through this entire example here just so you could see exactly what was going on. All right, so we did the trace. You can comment code in and comment code out. If you think, well, it's got to be somewhere in this code, then maybe, the code that's down below that, you comment everything out. Or above it, you comment everything out, depending on what you're doing and how you're doing it. As it says, that helps isolate whatever statement is causing your error. So when you comment out, don't comment out tons of lines of code at a time. Comment out a line or maybe 2 lines at a time. All right, you're much better off doing that. You can combine these techniques. So you can have alerts with logging, etc. All right. A dependency is a relationship where one statement depends on another statement executing successfully. Well, think about it. That's like an if. You will only execute the body of an if the if is true. Again, this can make debugging more challenging. It's always important after you fix the bug to retest because you might have introduced another bug. It happens all the time. All right. Now, talking about these debugging tools, again, I want to show you this. This is something that I like to do. You may or may not agree with it, but regardless, it's okay. I'm going to go out to youtube.com. All right, and I'm going to type in here Chrome Developer Tools. And you see I've already done it. Chrome Developer Tools tutorial. Now you're going to find 33,500 hits. Some of them aren't going to be very good. When you start looking through these, you want to look for 2 things. First, you don't want ones that are 2 or 3 minutes long because they're not going to be enough probably to help you. But now this one's 33 minutes and 40 seconds. Wait, Chrome Developers Tools can do what? Well, notice 77,000 people or 76,500 have looked at it. But also notice it's 3 years old, so it might be a little antiquated. Here's one that's only 10 minutes long, but notice it's from 5 months ago. The other thing you want to do is when you look at these, 603 likes and 8 dislikes. And again, you may look at this 33-minute presentation and not agree with that, but if that many people have taken time to vote on it, probably it's a fairly good indicator of what's right and what's wrong. All right, not only is there the Chrome developer tools, there is a thing from Firefox that's called Firebug. And there's Firebug tutorials that you can look at, and you can do the same thing. All right. Internet Explorer. I don't know if it's tools. I don't know what it's called. Debugger tutorial. All right. How to debug JavaScript code in Internet Explorer. But again, notice they're very small. They're 2 years old. They might be good. They might not be good. The good news is you're investing 5 or 6 minutes of your life. All right. And I'll look at this one. This is the JavaScript one. And we notice here it's got 11 likes and 5 dislikes. So it might not be that good.
Just for you, with unique features.
Welcome to jQueryExampleCode.blogspot.com. Using this video, we are going to learn how we are going to debug JavaScript code in the Internet Explorer.
And you might like that, you might not like that as you take a look through it. All right. So they go through here and they talk about the different debuggers that are available to you, how you open them, some shortcuts, etc. I say pick one and stick with it. All right. Now, again, I would recommend the Chrome and the Chrome developer tools. But it's probably good for you to try all of them and see which one you like the best, see which one makes the most sense to you, and work through that one. All right. They all are very similar in nature. So I have no desire to go through the picture for IE versus the picture for Firefox. Again, this is the one that I use. And they're, again, just so you know this, some things that you may or may not want to consider. How about this? Chrome developer tools. Is there like a cheat sheet? And it looks like here there is one. I don't know how good this is. I've never looked at it before. But what you get on a cheat sheet like this is a list of commands that someone has put together that makes it easier for you, because rather than having a lot of stuff, and how do I do this? How do I do that? You can bring up the cheat sheet and have it at your side, so as you're going through something, you can just take a look at the cheat sheet. And there it is. So it shows you how to jump around and go from different place to different place in there. And my guess is if you printed this out, it would be what? I can't see it from there. So, but my guess is maybe 3 or 4 pages. All right, even let's say it's 6 pages. You print it back to back, that's 3 pages. All right, these things also allow you to set what are called breakpoints. All right, what do I mean by that? First of all, I can close my calculator now. That's a good start. And I want to make sure I am taping. I am. All right, a couple times I've done that where I'm 20 or 30 minutes into a tape and I realize I never turned it on. So stuff happens. Okay, so I come in here, close a couple of these, and I bring up my file again, okay, and I go and run it again inside of Chrome. I hit F12, bring that up. Now, rather than running the program, etc., like this right now, all right, if I want to, okay, I did the Control O to see which of these files I could bring up. So I'm going to bring that up. And now it actually is in here. If I wanted the system to stop when it got to a certain point, I can click over here, and you see how it turns blue. That's called a breakpoint that I just put in there. Now, it doesn't make sense where I just added. If I click again, it goes away. But if I bring up the other file, and I bring up this functions file, I can come in here now, and I can say, hey, when you get to this point right here, I want you to stop. All right, and notice when I run the program now, see how it stopped? A breakpoint says stop execution at that point. So I can go back and I can look at different things if I want to right now. Notice I can take my mouse and put it over net pay and it shows me what it was. It shows me what my gross pay is. Shows me what my federal taxes are, etc. So it's a way that I can walk through and take a look at what's going on in my code. Again, you can use the different debug tools that are available to you once you have hit a breakpoint. I showed you how to set it. All right, and if there should be a continue button or a resume button here. So if I come back to it again, somewhere here is a resume button. I don't know where it is. Paused in debugger. Click there. Okay. I can remove that if I want. But someplace in here is a resume. Okay. So I can basically tell it to continue on. All right. A lot of times what I like to do is come right down when I'm right here at the bottom, right before this return statement. All right. And then run the program again. Now it's stopped. Why did I do that? Well, now I can look at everything. So I can take a look at my Medicare and see if it looks like it was okay. I can look at my federal. I can look at every single thing because what I've done is I've said, hey, right before you finish, stop. So I can check my values to see just exactly what's going on. All right? Everyone debugs in a different way. So here's some breakpoints being set. Again, to clear it, just click right on where you just set it. If you want to click all of them, as it says, you can right-click any breakpoint. And then there'll be a thing that comes up that says remove all breakpoints. There are ways that you can step into and step over and step out of scripts. Now let's look at each one of these. Step into executes an individual line of code, then pauses until you tell it to continue. The debugger stops at each line within every function. So let's look at that one. All right, I'm going to remove that breakpoint. And now, instead of running my program right here, okay, I'm going to come through and I'm going to tell it to start stepping. So which one do I want first? I want step into. So one of these says step into. I've done this before. Oh, the problem is this says step into the next function. I only have one function in here. Everything is in main. So there's nothing for it to step into. All right. I can step over to skip calling functions. I can step out. Now, where some of this stuff is nice is, let's say I'm doing a step into where it's executing every individual line of code one at a time, and I get into a loop that's going through 100 times. Then I get step 100 times. That's kind of silly. So I might want to do a step over or a step out when I do something like that. You can set traces on variables. All right, you may or may not have noticed when we looked over here, we've got windows. We've got a watch window right here. And we can put expressions in there. We can check for certain things if we want to. So if I wanted to check for Medicare, all right, as an example, it says Medicare is not available right now. Well, let's come right here and let's try to check for pay rate. All right, it says it's not available. Well, it is available. All right, I did want to show you, if I click here and right mouse click, okay, remove breakpoint, and if there's several of them, I right mouse click. I thought there was a way to remove all of them at once, but I could be wrong on here. All right, you can see in many ways I'm a novice at this, and I'm not going to lie to you and try to put one over on you and say I'm not. You learn by doing and doing and doing. All right. when you add watches and you add some of this stuff, what it'll do is, once you do it correctly, is as you go through the program, it'll show you the value of a variable, and especially as it changes. The call stack, let's say that I've got a program, all right, and you've already seen this stuff, so file, let's do a save as here, we'll call that 3.txt. So let's say that I've got a program, and in my program, I've got a main. Oops. And what main does is it calls function 1. All right, so that's a call right inside of main. Then I've got function 1. Kind of a silly name. In fact, let's call it function 1 like this because it'll make it easier. I won't have as much typing to do. All right, and what that does, and I'm going to keep it fairly simple, but that calls function 2. And function 2 calls function 3. We're going to leave it right there. All right. And we'll put an alert in here that says, I'm in function 3. That's all we're going to put. Okay, and that's it. Then we're going to put a similar alert here, here, and here. So here this is going to say I'm in function main. This is going to say I'm in function 1. I'm in function 2. So the idea is, what I'm trying to show you is if we talk about what the call stack is, main calls function 1 calls function 2 calls function 3. All right, so the call stack is, always has the last function that was called. So the call stack would say function 3, and then it would say function 2, and then it would say function 1, and then it would say main. The reason that the call stack can be very important is if you get an error, and if it's a very egregious error, a lot of times what the system will do is it'll dump the call stack. So it'll show you where errors are. Some of the errors might be in your code. Some of the errors might even be in JavaScript's code itself. But if you find that, the error is in your code. It's not in JavaScript's code. All right? So the call stack is defined there as an ordered list of which procedures have been called but haven't yet finished executing. Every time a program calls a procedure, it gets added to the top of the call stack. All right? And IE and Chrome and Firefox all let you play with the call stack. All right. This is almost a funny slide because it says bulletproofing. Writing code to anticipate and handle potential problems. There's no way to totally bulletproof any code. It just doesn't work. All right? Okay. There are ways that you can make it easier, though. And you can use exception handling. An exception is an error that occurs in a program. I've talked about this before in other classes, but exceptions are exceptions to the norm. So an exception in programming ease is something abnormal. So you handle exceptions by writing exception handlers. As it says, that allows programs to handle errors as they occur. If you don't handle program errors or exceptions, the system will. It'll try to look for some way to handle it, and if it can't find any, it finally throws up its hands and says, that's it, and the program just aborts. All right? You can do what's called throw your own exceptions. So here, you're putting some code in, and it says we're checking for a last name, but if it's blank, you throw an exception, so literally what's going to come up on the screen is a message that says, please enter your name. Now, typically the way that you write this stuff is you use what's called a try-catch block. All right, so let me move this down a bit, or up a bit, I should say. So typically you put a try statement here. And then you put, I'll put this in here as a comment, one or more lines of JavaScript code which could conceivably fail. All right? And then here you've got one or more statements that say catch. So this would be some error. All right? It doesn't literally say some error, but that's what you do. Handle the error. Now it's possible you could have all sorts of different kinds of errors. So you can have more than one catch statement in here. So this would be some other error. And if you want to, at the bottom, you can even have what's called a finally block in here. And this always runs. So again, let's play some computer here. You try to do a bunch of code right here. You have no errors in your code. So it skips this, and it does this. All right? Or you try to do some code. This fails. So the system looks and sees if you have, oh, that's the error. So it does that code. It skips this code, and then it does this. You try to do some other code. Well, that's okay, but this has got an error in it. Oh, there's the error there. So it finds that catch statement, it handles it, and then it does the finally. So it either does the try, everything succeeds, and you skip all the catches, and you do the finally, or it does the try, and one or more statements fail, and you catch it someplace, do that, and then the finally. You never have to put in a finally if you don't want to. Typically, you use the finally clause that's in there for housekeeping chores. So if you've got a database open, you might want to close it, or a file open, you might want to close it. All right, so I've explained all that already. So the primary purpose of exception handling is to try to have you handle your errors. It says provide a graceful way. That's true. But again, if you don't handle your errors will be handled by the code itself. All right, or by JavaScript itself. That's almost always not going to be what you want. So you can also write your own error messages that explain what's going on, because a lot of times the ones that JavaScript writes are rather terse. They're hard to understand what's going on. You catch errors with what's called the error event. JavaScript interpreter automatically passes 3 arguments to any custom error that you put in: a message, a URL, and a line number. You can use these, all right, when you're printing stuff out. There's other things that you can do for debugging. The biggest thing, again, I've mentioned this to you previously, is what a lot of people like to do is they like to go and print out a hard copy and start playing computer and going through it yourself. That's always the best way to both learn, all right, and find your mistakes and fix your mistakes. Notice it says perform a line-by-line analysis. And the problem could be virtually anywhere. It's possible the problem's in your HTML. It's possible if you've got CSS, it's in your CSS. It's possible it's in your JavaScript. You want to narrow down where the problem is, and so you can start looking for it. All right? Again, if you've got a logic error, it's probably then it's going to be in your JavaScript, and those, as I mentioned, are the hardest to find because you don't think you did it. You now know how to use the console if you want to do that to check out things. All right, there you can put a debugger statement in your code. It's the equivalent of a breakpoint, and we'll go over that in class. There's also, this is kind of neat, all right? And I want to show you this again over here, and that's the use of strict mode. So if I came in here, and let's see, I've got pay rate right here. See that? But somewhere later in my program, when I'm using the pay rate, all right, and I guess it would be is pay rate a bad example? Yeah, because it's only used once. Let's say net pay, because we've got, well, here we got federal taxes, right? That's used in a bunch of places. Yep, it is. Okay, so let's say that where I said federal taxes here, over here I did this. I put a T in there that's not a capital T. Remember, JavaScript is case sensitive. What happens when I do that is JavaScript creates a brand new variable called federal taxes with a lowercase t. Let's see if that's indeed the case. I'm going to save this. I'm going to come back and run this again. And I'm going to bring up my Chrome Developer Tools and then run the program. Oh, I don't want this up anymore. Let's see. I'm going to go back down to my console on the bottom. There we go. See that? It did come and say uncaught reference, federal taxes is not defined. So it found that for me. All right. Sometimes, though, what's going to happen is JavaScript will just create a brand new variable for you. And it will say there federal taxes are 0. But if at the top of your program you put in, and I want to give you the right syntax, I think it's just use strict. There it is. Include the statement. I think you actually need it just like that, with the double quotes and everything. So you put it in there like this. All right. What that does is it literally tells JavaScript to use strict mode. And if you happen to make a mistake like the one we just mentioned, catch it and flag it right away. All right. So if you use strict mode, you're again trying to cut down on the possible errors you could have. All right. JSLint is a program that you can use. It's a built-in JavaScript, not built-in, but it's a JavaScript program that you can call that will run through your code and look for common errors. Okay? You can try to reload the web page. Don't just keep, when I say reload the web page, usually you just click the reload button, but sometimes you may need to totally close your browser window and then open it again. So we've gone through debugging. We're now through the first 4 chapters of our text. We talked about the 3 basic types of errors, those being syntax errors, runtime errors, and logic errors. We talked about different ways that you can trace error messages, including the console.log and some of the debugger tools. In the debugger tools, we talked about things like break mode and breakpoints, the call stack. All right. We talked a little bit about how you can try to bulletproof your code, and we ended by talking about exception handling. So that's it for Chapter 4. All right. And I'm finished. And that's probably it for the night, but the next chapter that I go over then will be Chapter 5, and I believe Chapter 5 is on the document object model. It is. It's a little longer than most, and it's one of the more complex chapters in your book. So we'll get to that one next.